Okay, so we're going to consider these two equations, all right? We have this differential equation and this differential equation. Equation 1, so this one right here, equation 1, is in the first order because the highest derivative that appears in it is the first order derivative. In the second equation, which we'll call equation 2, we see the second derivative being taken, which makes this a second order derivative, okay? So if we have a first order derivative, it's a first order equation. If we have a second derivative, it is a second order equation. Now, they are both linear. You can tell by the shape because y prime, and y double prime are not squared or cubed, and their product does not appear. In other words, we do not have terms like y prime squared, all right, so that's not squared, or we don't have y double prime cubed. If f to the x and b to the x, respectively, is 0, then each of these equations is what we call homogeneous. All right, so if it's equal to 0, or if our differential equation is equal to 0, it's what we call homogeneous. If it's not equal to 0, it's equal to something else. It is non-homogeneous, and that's the difference between first order, second order, homogeneous and non-homogeneous. One other point, if a to the 1x and a to the 2x are constant, then we say that equation 2 has constant coefficients, which is helpful in other ways.